In this video, we're going to look at quadratic functions. And so here's the definition, and then we'll do an example. A quadratic function is any function that can be written in the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers and a does not equal 0. Now, if a were 0, that would get rid of this term right here and leave us with a linear function, which we talked about in the last video. The graph of a quadratic function is a parabola. What does a parabola look like? We'll see it in this example. Let's graph this quadratic function, and this function is f of x equals x squared. Now this fits this form, ax squared plus bx plus c. For this function, a is 1, b is 0, and c is also 0. This is basically the typical quadratic function we look at. And in fact, we'll compare all other quadratic functions to this one. All right, let's take a look at this function. So if we want to plot it, let's make a table. So we'll have x, and then f of x. I'm going to go ahead and write x squared. This is f of x. And let's pick some x values. Let's start with, say, negative 3. Negative 3 squared is positive 9. Negative 2. Negative 2 squared is 4. Negative 1. Negative 1 squared is 1. 0. 0 squared is 0, so the origin will be on the graph. 1. 1. 2. 2 squared is 4. And 3. 2 squared is 9. All right, that's a good set of points, going from negative 3 to 3. And let's plot those on our graph. We've got the origin. I'm going to go ahead and plot the origin on there first. And now we have 1, 1, so over 1, up 1. And we also have negative 1, 1, so to the left 1, and up 1. And we have 2, 4, so we go over 2 and up 4. 1, 2, 3, 4. And we also have negative 2, 4, over 2 to the left, and 1, 2, 3, 4. All right, we have 3, 9, and negative 3, 9. 1, 2, 3. And we'll go up 1, 2, 3, 4, 5, 6, 7, 8, 9. And we'll go through to the left and also up 9. All right. Now here we can see the shape that's developing, quite different than the linear functions, which are just straight lines. And this has a more U-type shape. And let's go ahead and complete the graph by connecting these with a smooth curve. This way. This way. All right, this is the general shape of a parabola. It comes down here, it has a nose right here. It comes down, hits the nose down here, and starts to turn and goes back up. All right, these points, this point here where the turning happens is given a name. It's called the vertex. So let's look at the vertex. So the vertex here for this particular quadratic is the origin, 0, 0. And this is the point where the parabola changes its direction. So to the left of the vertex, in this case, the graph is decreasing, but once it reaches the vertex, afterwards it becomes increasing. There's another feature that parabolas have, and that they are symmetric across the vertical line that runs through the vertex. We can see that here The y-axis acts as this vertical line. The right half of the parabola matches the left half of the parabola. And so we call this line the axis of symmetry. And you can always find it. It is the vertical line through the vertex. In this case, the axis of symmetry is the line x equals 0.